Greetings from San Francisco, California. My name is Jordan Taylor, and I, along with Professor Dr. Padmapriya Jayaraman, are the co founders of the not for profit ProjectHarrison.org, an organization dedicated to exploring maritime informatics in the age of artificial intelligence. It's an honor to join the Global Compass Forum here in beautiful Varna, and I thank Captain Paskov and the conference committee for the opportunity to speak with this accomplished group of shipping professionals. I also want to recognize Bulgaria's strong commitment to maritime digitization, reflected in significant academic publishing activity, and in the work of Captain Nikolai Bedzev in marine simulation engineering, who is preparing the next generation of maritime data specialists and informaticists. Bulgaria is setting a clear course in maritime digitization now and in the future. For those who may not know me, I've been in the commercial maritime industry for almost 30 years. I sailed as a deck officer for 10 years, mostly on VLCCs and in the capacity of third, second, and chief officer, and did shore operations both on the technical and commercial side in products and chemicals, and taught nautical science and maritime data science in a university setting. I've concurrently been a computer programmer since I was a child, where from time to time I publish peer-reviewed work on the subject of maritime informatics, culminating in a Fulbright Specialist grant by the US State Department in 2024, one of the highest academic honors in the United States. I was the first professional mariner to be awarded this type of honor in United States history. Today, I would like to speak about my favorite topic, generative artificial intelligence and its real-world applicability to the commercial maritime industry. For those less familiar, generative AI refers to computer models that can create new content, text, images, or code based on patterns learned from large amounts of data. Unlike traditional software that follows fixed instructions, these systems can generate responses, summarize complex documents, or draft entirely new material that resembles what a human might produce. McKinsey Global Institute estimates that generative AI could contribute between 2.5 and 4.5 trillion in global economic value each year in the coming decades, largely through productivity gains. To put this into context, that annual figure is comparable to the total global ocean freight revenue across all cargo types, liquid, dry, and container, over a 5 to 10 year period, according to Clarkson's. So the question is, how will generative AI affect us as shipping professionals? Within maritime operations, we see three practical areas where generative AI already has relevance: access to information, communication between humans, and communication between humans and machines. I want to be clear that in each of these areas, AI is not replacing shipping professionals, it is augmenting them. This approach is often called human in the loop or HELO. I'll drill down on the three applications with practical use cases. The first application is access to information. Many of us already know that generative AI can support this. For example, the shipping industry is one of the most regulated and paperwork-heavy industries in the world. In the United States, port state regulations encompass around 7 million words alone. As many know, non-compliance with port state regulations of any country may not only result in fines, but also jail time for ship's officers. Generative AI may serve to reduce paperwork burden on crews and shore operators, provided the information relayed to the user is timely and correct. The second area is human-to-human communication, especially across language and cultural barriers. Communication within the maritime industry comes in many forms. For example, voice communications and email communications. One example is working with international crews, of which I would bet that not one shipping professional listening to me right now has not worked with another shipping professional of a different country, language, and cultural background. Indeed, shipping is global. In this way, generative AI may help bridge the gaps between language and cultural understanding of others. When crew and shore dynamics matter, this is a valuable use case. The third application, which I don't see mentioned very often, is a relationship of a human to shore or vessel systems. In other words, communication with machines. For example, at sea, crews rely on feedback from user interfaces to reduce operational risk. As many who have been to sea or use shore vessel management systems know, bad systems can heighten risk. I strongly believe that language models, if properly placed, can improve communication between machines and their respective human operators and engineers. This could take the form of decluttered user interfaces, timely, helpful suggestions to vessel operators, or models combing through sensor data to identify risky patterns or behavior. The challenge here will be ensuring compliance of generative AI with high risk AI frameworks as related by the European Union's Artificial Intelligence Act. One question of application often gets discussed is how generative AI will affect the commercial side of shipping. Shipping, as we know, is an old industry. Shipbrokers predate the telegraph, and bills of lading can be found on clay tablets during the Roman Greco era. Some believe that the intermediary between the owner and charter is a key element of global shipping, much like physics will never go away. Others believe that it may take mass consolidation of intermediaries. This remains a question that, in my opinion, no one can answer presently. What I find most interesting are the solutions that will be generated by individuals and often young and motivated shipping professionals working alone or in small teams. This will absolutely happen. AI powered tools such as Replit, though new and incipient, will give individuals the power of application development and may one day supplant the need for spreadsheets, which are used by 1.3 billion people globally. I strongly believe Excel dominance in shipping offices will eventually give way to app development. So, in my opinion, that young operator who is working on a side project, encourage and support them in that endeavor. It may very likely result in cost savings for the organization. I would like to briefly mention what AI will not affect. A brand new study by Microsoft in May of 2025 lists marine engineers and deck officers at number 9 and number 32, respectively, as the least affected by generative artificial intelligence among all global industries. This, combined with the mathematical impossibility of annotating training data from marine vision models, among other reasons, makes, in my opinion, commercial autonomous vessels a non reality. I apologize to those here that believe mass has a future, but as someone who's trained vision models myself, I find quantifying the unquantifiable as a fool's errand and not worth our collective energy. The only place you will see it now is for military application, because, simply put, the military is an unregulated entity. I'd now like to briefly turn it over to my colleague, Dr. Padmapriya Jayaraman, a trained electronics engineer who has a PhD in artificial intelligence with a specialization in vision models and robotics.
Distinguished guests, colleagues, and leaders. Throughout history, one simple tool transformed the way humanity crossed the seas: the magnetic compass. It did not make sailors obsolete, it made them stronger, braver, and more capable of reaching horizons once thought impossible. Today, another compass is emerging. It does not point north, it points forward. It's artificial intelligence. And the truth is this: AI is inevitable. The question is not if we will adopt it, but how wisely we will navigate with it. Three unstoppable forces are driving this inevitability: economics, safety, and sustainability. The International Chamber of Shipping estimates AI driven voyage optimization can cut fuel consumption by 10 to 15%. That is millions saved per fleet year after year. According to Allianz Safety and Shipping Review 2024, 75% to 96% of marine accidents still stem from human error. AI systems, whether in navigation assistance, traffic management, or predictive maintenance, can detect risks long before humans notice them. In the respect of sustainability, the International Maritime Organization IMO has committed to net zero greenhouse gas emissions by or around 2050. AI integration is one of the few realistic pathways to achieving this, from real time emissions monitoring to optimized routing that cuts unnecessary fuel burn. Let me be clear. My intention is not to suggest fully autonomous ships taking over our seas. Instead, the real power of AI lies in integration with human expertise. In Rotterdam, AI helps predict vessel arrival times with 20% greater accuracy, supporting harbor masters and pilots but not replacing them. In Singapore, AI tools manage vessel traffic in one of the busiest waterways in the world. On board, AI predictive maintenance systems alert engineers to mechanical failures before they happen. But the potential of AI goes far beyond ports and ships. Allow me to share an example from my own work. In agriculture, I developed a drone integrated with computer vision and robotic arms for eradicating weeds in paddy field. Traditionally, weed removal requires intensive manual labor or excessive use of chemicals. With AI, computer vision can detect weeds in real time and guiding precise interventions. The result is higher productivity, lower cost, and reduced environmental impact. The lesson is simple. Whether in the sea or in the soil, AI does not replace human effort, it amplifies it. It helps us work smarter, safer, and more in a sustainable way. Every technology carries risk. AI is no exception. The World Economic Forum warns that cyber attacks on the maritime sector have tripled in the past 3 years. The more connected our ships and ports, the more vigilant we must be. If an AI system is in error, who's responsible? Maritime law must evolve to address these gray areas. AI will not eliminate seafarers, but it will change their role. Tomorrow's mariners will need to combine seamanship with digital literacy, able to be aware of how systems work and how to address misinformation as naturally as they now read a chart. The inevitability of AI also means the inevitability of responsibility. When the compass was invented, it did not eliminate the navigator. It gave the navigator confidence in uncharted waters. The compass transformed exploration. GPS transformed navigation. Artificial intelligence has the potential to transform the very future of maritime trade. But let us be clear, this transformation cannot be left to chance. We must not drift with the tide of technology. We must chart its course. That is why the IMO, maritime law, and our regulatory institutions must lead. Leadership today will decide whether AI becomes a tool of progress or a source of risk. If we hesitate, adoption will be fragmented, unsafe, and unequal. So, I leave you with this thought. AI is not the end of seamanship, it's the new compass in our hands. The responsibility is ours. The horizon is wide, and the time to set our course together is now. Thank you.
Thank you, Dr. Jayaraman. I'd like to continue by asking a practical question. If AI is our new compass, how do we evaluate it for use in the commercial maritime industry? So, how do we evaluate generative AI for commercial use? From my perspective as a former mariner and shore operator, the approach is straightforward. We apply large foundation models to verify data and information to generate outcomes. Those outcomes must then be benchmarked and measured with confidence and accuracy levels explicitly assessed. In the case of high risk AI applications, an IMO approved risk assessment process must be established and in place. That's really it. For better or worse, the genie is out of the bottle. Our task now is to wrangle data and information in a way that can be used by artificial intelligence in a responsible way. In fact, we've already done this in the maritime industry during the advent of ECDIS in the 1990s. At Through the eventual development of S57 standards and now S100 frameworks, we are now tasked to do it once more within the context of AI reasoning tools. The downside of generative AI: irresponsible use and/or malicious propagation of misinformation. We are already seeing it. At Project Harrison, we ran an informal study in 2024 of maritime informatics companies that purported to either be using or developing AI. We found that 95% of these companies had no defined problem statement, method, or outcome. There was no evaluation, accuracy, or confidence score for their purported models. In a word, there was nothing. So we're already seeing companies trying to use misinformation for garnering investment money, and I see no end in sight for the snake oil salesman approach. However, the largest misinformation risk is the introduction of bad AI systems into high risk environments. As a collective industry, we've made incredible strides in safety management. In fact, we're the safest we've ever been. And it's a testament to training, professionalism, and work of mariners, ship owners, and governmental agencies, among many others globally. It is the biggest win in our industry in the past 30 years, and one that frankly goes unrecognized by the general public. We are already seeing bad AI. Who has not seen a deck officer or pilot using an app or non approved device on the bridge of a ship? I personally sailed on my license within the last 2 years. At least in the US, this is a persistent problem, and one that is propagated even by senior and command level officers. With generative AI being applied to many off the shelf applications, the chance of misinformation making its way to the bridge or engine room is a real possibility. This, in my opinion, must be stopped. We need a sanitary bridge environment with regards to data and information, as well as for critical systems ashore, such as VTS. The first mitigation step is twofold. The International Maritime Organization must work on and publish high risk, medium risk, and low risk AI assessment framework that aligns with the European Union Artificial Intelligence Act. This is an absolute must. There are existing frameworks out there. Here in San Francisco, the University of Berkeley maintains a working document. Therefore, the IMO would simply be tasked with adopting the framework for maritime use. There will be resistance from the industry with regard to end-to-end visibility and training data, and the cost of continuous monitoring with high and possibly medium risk solutions. We are already dealing with this in the autonomous car industry here in the States, where we feel that some companies are actively circumventing safety regulations for a profit motive. The second step is training our future shipping professionals in data science. We cannot ignore this situation any longer. Mariners must be digitally competent, be able to identify misinformation, and be able to use future AI systems in a responsible manner. I know often our community by choice has one foot in the past. I understand. We are a millennia-old industry and we have a rich heritage. But digital education and training must be adopted across the board and within STCW, not only within broader nautical science and business of shipping curricula, but we desperately need maritime information specialists as well. We as a shipping community are being left behind. This is not a US issue or Indian issue or Bulgarian issue. It's a global issue. Many of us know that in the early 2000s, our bridge resource management techniques were adopted from the aviation industry, a relatively new industry in a situation we should have been collectively embarrassed by. Let's not let this happen again. However, I want to be absolutely clear. The responsibility for assessing the risks of generative AI must not fall on the mariner or shore operator. Professionals at sea and ashore need awareness of these systems, but not liability for their failures. Systems must be designed to be human-centric, reducing or eliminating the burden on the operator. There must be no culpability for the end user. I believe this principle should be written in the IMO policy, with accountability for failure placed squarely on the system designers. To see what responsible innovation looks like in practice, we can look to Bulgaria. A standout example is the Naval Academy in Varna, led by Admiral Professor Dr. Kalin Kalinov and Dr. Nikolai Bedzev, the latter a global pioneer in simulation engineering. Dr. Bedzev is developing a new generation of postgraduates and PhDs who are at the forefront of maritime digitization, positioning Bulgaria as a current and future leader in this field. The commitment to meaningful, cutting-edge work is exactly why I traveled from San Francisco, arguably the world's tech capital, to Varna in August of 2025, where the most important advancements are truly taking place. Bulgaria matters. Before I close, I would like to again thank Captain Paskov and the Global Compass Forum organizers for the opportunity to join this forum. For anyone wishing to know more about Project Terrace and its mission, I invite you to connect with me or my colleague, Dr. Padmapriya Jayaraman, on LinkedIn. Our goal is to advance AI-first maritime informatics by building tools, data, and applications that serve the shipping community directly. Thank you.